As we get to lesson 12 of chapter 1, this deals with applied word problems. And I know sometimes word problems can be intimidating, but just try to follow a procedure here. First of all, we've got to read. And you might read through quickly for a general view, but then you need to reread slowly, carefully, listing the information that you know. Try to identify the unknown quantities and choose a variable to represent that. Specify the other unknown quantities in terms of that one that you chose. If it's possible, make a sketch using these known and unknown quantities. Then step 5 says, and analyze the statement of the problem and write the necessary equation. This is because sometimes some of the information is implied and it's not explicitly stated. So here again, we need to read carefully. So we might have to reread the problem yet again. And then we're going to solve that equation, stating what the solution is, and then check it to make sure it makes sense for the original statement of the problem. So let's look at this problem comes from your textbook. Is example 2 on page 47, and you're designing an office complex. An architect planned to use 34 energy efficient ceiling lights. Okay, that was going to use a total of 1,000 watts. Now, with these lights, he has two different types he wants to use. One has a 25 watt and the other one uses 40 watt. How many of each were planned? Since you want to know the number of each type of light, we need to let X represent one of those unknowns. So we're going to let X represent the number of 25 watt lights. Now there's 34 of them in all, so that means the number of 40 watt lights has got to be 34 minus X. So that's that next step in the procedure where we identify this other unknown in terms of the first one. And since we also know that the total wattage of all the lights is 1,000, that means the number of watts used by those 25 watt lights plus the number of watts used by the 40 watt lights is going to give us a total wattage of 1,000. Now, this idea of the sketch, you know, looking at this problem, what you might want to do in your little sketch is think, oh, I've got 34 lights total. And for those 34 total lights, if I let X be the 25 watt ones, then the 40 watt ones are 34 minus X. The power that those 25 watt lights use is 25X. The 40 watt lights is 40 times the number of 40 watt lights. And add those two amounts of wattage together to get the total wattage, which is 1,000. Now, once we do that, we end up with this equation here to solve. And in solving this equation, we want to go back and use those little techniques that we considered earlier. So we want to, in the problem, we've got 25X and minus 40X. So we're going to put those two terms together. Those are like terms. And that's going to give us that negative 15X. And then we're also going to, they have done this in one step, is move this plus 1360 by subtracting that on both sides. So if I take 1,000 and subtract 1360, that gives me this negative 360. So now my last step is to divide both sides by negative 15, and we end up with our answer being X equals 24. Now we have to remember that's the number of 25 watt lights. So if there are 24 of those and there's a total of 34 lights, then there must be 10 of the 40 watt lights.